G'day YouTube, Javier from Oz here. So today is my first day back after a couple of weeks holiday, headed back to work, and luckily I was able to complete a few projects over the time, one of which is my entry into Emma's toolmaking competition. This is a project I actually started last year for the toolmaking competition, with the intention of finishing it, and yeah, that fell by the wayside. A whole pile of things came up that meant I was not able to get it done. So I picked it back up again this year, and essentially you're going to see me build a 3D printer. Now this is a third generation 3D printer, in that it was printed by a printer that I printed, which was also a printer that I printed. So my original printer, which is this one here, was a Prusa i2, this triangular frame. When I finished that one, I was reasonably happy with the results, but there were limitations. So I printed the parts to make a second printer, this one here. And a few years down the track, I started making kits and selling those kits. So that was the third generation. This machine is actually one of the kits that I made. And I'm building this one up for a friend of mine. So yeah, look, third generation 3D printer in my own printer laboratory, or what would you say, puppy farm. And finally got it finished last night. Along the way I've learned a whole pile of different things, and I'll try and show some of those in this, and also some of the previous, which I'll link to here, which is the playlist of building the 3D printer, the Prusa i3. Modern variants you can buy fairly cheaply on eBay or Chinese suppliers, and they typically all think that they're going to improve it some way, or change it some way, or make it better some way. One of the things I was really surprised about with the very first i3 that I built was how unconstrained everything was, and yet how well it printed. Things like the top of the Z screws aren't constrained. The Z lead screws are a very thin 5mm rod, so they don't overpower the 8mm vertical slides. Everything's just that extra finesse towards, I guess, the ultimate goal. Now, I don't use end stops when I build printers, because it's just another complexity, another expense, and it's another inaccuracy, because, I mean, every time you're hitting a repeatable sensor, it's going to debounce a couple of microns or millimeters or whatever. And I especially found with Z that my Z heights were always slightly different each time I did a Z home. So even with optical sensors, I found I wasn't getting really crash hot results, and it was another $10-15 worth of parts. So on this printer, as my other i3, and indeed my i2, I never bothered with end stops. What that means is where you turn the printer on is where its zero home position is. So when I do a slice of an object for print, at the end of the print I bring home back to 0 in Z, which is really the only thing that is of concern, because the X and Y, you can basically push the bed back to a start point, which is close enough. The modern Prusas have all that stuff sorted. It is possible to do end stops well. I just, as I say, it's an extra complexity that I never worried about. And I guess the other thing is that the modern Prusas have power out recovery. So if you lose power, they know exactly where they are. They can come straight back and continue a print if the print fails. This one doesn't do that. Once you lose power, you lose your X and Y position. You can't rehome it anyway. so you might lose the position there. So look, there are pros and cons, but this is what it is, a 3D printer that prints remarkably well. And here you go, the final stages of building. I hope you enjoy it. So this is a long-awaited update on the How to Build a 3D Printer project. You may remember I started this one last year as an entry into Emma's spare room toolmaking competition, and then got distracted with the lantern tool post. But time has come, the competition is up again, it's time to build a 3D printer. So far what I've done is I've joined the X and the Y together on the frame. I've positioned the carriage. I've positioned ball bearings under M5 rods with plastic adapters here. And I've positioned the gaps here, and I've also checked the alignment for square by just doing a simple eye check across the vertical of the plate to the vertical of there, and the same over there as well. Very simple checks like that, just make sure that you're building a square printer. I've done the same thing looking down the plate to make sure that we're square across the back. And these simple checks are ways that you can make sure that your printer is actually X, Y and Z square without specialist tools. Now, attaching the bed is a bit of a trick. As the bed heats up, it will expand and contract. So it's important that you only fix one corner, if any corners. Here I've got some fibre washers and I've got some nylops. So I'm going to clamp it so it's firm but not so it's overly constrained. And that will allow the bed to flex without bowing, because one of the main causes of print variance is a cyclical temperature change in the bed, which causes the print to rise and fall as the print is happening, which is why you get like a wave in the side of a Z-axis as the printer is printing. How you can tell it's that's causing it rather than a Z alignment or a Z-axis wobble is firstly that it will expand out both sides of a print as opposed to just wobbling up the print. And the second is that it's not consistent with the size of your object. So if you've got a small object, it will tend to have a much slower period than if you've got a large object where it will be a much tighter sort of period on the change. One way to deal with that is to keep these bolts fairly loosely constrained. The second way is to make sure that you use bed PID tuning, which is to make sure that your heater is floating as opposed to bang bang, which is kind of all on, all off, because you tend to get a lot more hysteresis around the target temperature with that. So, the Mark IIA print bed, the Prusa frame, I've just got some nylon and 2 fibre washers, an M3 cap head bolt, and then an M3 nylock underneath. I'll bring you back once I've got those fixed up. So we're now firm to the bed. You notice that the bed still has a little bit of motion in it, and that is just to do with the way it sits into the bearings. And it's not actually a problem. A lot of the constraints that people place on these printers aren't actually required, and many of the aftermarket suppliers tend to overly constrain their printers and end up with worse print results. It's a surprisingly forgiving platform. Anyway, now I've got to run this cable. Okay, so we've now got some strain relief on the bed and then through our cable chain attachment point. Now, these cable chain attachments are on my Thingiverse page if you want to add these onto your printer. And basically it's just going to allow the run to be maintained and managed. Bring you back when that's on. Alright, so there we go. That's the cable chain assembly fitted up. Ready to turn it back over. Here's some more tuning tips you may not know about 3D printers. As any of the axes moves left and right, you want the belt travelling between the stepper motor and the attachment point to be horizontal or parallel with the axis. That ensures that you don't have any cosine error with your steps per millimetre on that belt. You'll also notice here I've had a really quick, cheap hack, which is to just put a bit of downwards pressure here with a cable tie, which keeps the other end parallel. With this flexing, instead of being parallel, the length of the belt would actually change depending on where the head was, which would put a different tension on the belt and would lead to inconsistency in the print. So just by pulling that down, we've essentially made the belt the same length regardless whereabouts in the travel it is, and taken out one extra variable. So we've got parallel to the axis, and we've got consistent length belt throughout its travel. I've done the same on the Y. It's got a full length belt. I've also got this clip in behind the Y stepper, and what that does is just provide some force counteracting the rotation force of the tension on the belt. It's not super tight, it's tight enough. Okay, the Arduino. Previously with this machine, it would get to a certain height and then bounce and produce a print error. And I believe that the issue was that this stepper here was actually striking on the LCD screen board. So I've just added some extra spacing here on the Arduino to pull it further away, which means we've got clearance to this. So clearance throughout all of the axis travel is very important. Come around to the front. On these 5mm, I've got a ball bearing inside both sides, and I've just released these up, and you can see that there's free travel up that axis as well. So making sure that you have free travel on all axes across all travel of the various shafts is important. The bed I've now got on here as well, and what I typically use on these beds is a mirrored tile, 200 by 200 with a 5mm bevel. Oh no, this is a flat edge, which is fine. And they're easily available from Bunnings and so forth. And this gives us a super flat build plate plus a really attractive printer. It's so nice being able to see the printer reflected in itself. These I just get from Officeworks, and essentially clipping on like this keeps us out of the way of the print. Now, next thing I want to check is at the end of the travel, I want to position the Z relative to the Y frame. Now, previous to now, I've just positioned it all to get everything in a general location. So now I'm doing some fine tuning. So at this end of the travel, I'm about 10mm past the end of the bed. And at this end of the travel, I'm at the edge of the bed. So I can potentially take this whole assembly back another 5mm so that the bed is sitting more centrally on the Y frame. So I'll do that now. I just loosened these bolts off, and I can now take the whole bed assembly up and gain that 5mm back. In addition to which, the cable routing goes through. And allows it to travel through to the other side here. Okay. So we now have power for the bed coming through the back. And mirror pretty good. Here we go. We have new firmware going in. USB connection, power supply, cabling, neatly wrapped around. The position for this I usually have up here, but that's something that Javier can put somewhere if he wants. But that's going to be me done, I think. So we've essentially made a 3D printer. Now let's see if it extrudes. Okay, so after a couple of shakedowns, we now have some really nice quality printing coming out, well calibrated. Printer's running quite quietly. I added some extra cables here and here because the Z was slipping. I've put some Slick 50 grease on the 5mm nuts because stainless on stainless will gall otherwise. Well, that's pretty reasonable. We'll come around to the back. I've added a cooling fan over the steppers and the large 10-amp fuse. The reason for that is that the bed temperature, or the bed can pull 12 amps maximum draw, and this fuse will only handle 11. So we've got the bed frequency dropped to 127. So I'd only do half power at its maximum, which helps to not trip that thermal fuse. Other than that, we've got our wiring wrapped up in behind the Arduino board. And everything else just buttoned up in behind as well. And that's how to build a 3D printer. It's just a power supply with a switch, running 12 watts and 2 channels, USB port, and then the 2 ribbon cable connectors for the LCD, and everything else has just been nicely wrapped up in here. And I'll leave it to Javier to design and print a housing for the LCD, wherever he wants to put it. Cable chains, and the 2-axis. Tidy up connection. And we have the fan, and the extruder. It's all put together and I think it makes quite an attractive 3D printer. The Prusa i3 Mark 1. This is Joseph's original Mark 3 design before all the Chinese copies started of it. His Mark 3 is a further improvement on this, much better, faster, stronger, better electronics, can print faster, all that sort of stuff. But this is a workhorse. This will print very nicely. So that's my entry, and good luck to everybody else who's entered. I hope to see your outcomes, and we'll see where everybody sits. Thanks for watching, and I hope you found this interesting. Bye now.